Hello, my name is Erick, a student from the University of Texas at El Paso, currently pursuing a master's degree. This project is a synchro model of an intersection between Doniphan Drive and Sunland Park Drive at the city of El Paso. The outline of the project would discuss the following: project description, a site description, software description, the provided data. And then we're going to see about the settings for volume, the lanes, how do we assign the NEMA movements or phases, as well as the signal settings, the LOS analysis, and finally the information we'll learn along this project. The outline of the objective of this project is to be able to code an isolated signalized intersection using the Synchro software. While coding the model, we need to take into account that our final goal is to perform an LOS analysis. A brief description of Synchro would be that it is a macroscopic analysis software. This software supports the Highway Capacity Manual, 6th edition, 2010-2004 signalized intersections. And to be able to use this software, I focus mainly on looking at the examples that the software already provided, as well as a variety of videos that gives an introduction to this software. The study area for this project is situated in the city of El Paso at the intersection with Doniphan Drive and Sunland Park Drive. For this project, the westbound right turn lane would not be considered, as it does not disturb the flow of the vehicles at the intersection. As we can see, it's a completely different lane. Only provided data, aside from the already discussed aerial photo, is the turn volumes. This was provided in a spreadsheet with volumes from different time periods in the same day, and our task was to come up with the highest volume on a 1-hour time period. Other data is the signal timing data plan. This is used by the city of El Paso, and this will give a better sense to our model on its accuracy. In this slide, we can see the volume settings. This is part of the volume data that we were provided, but only showing the highest volume. For this project, we neglect the U-turns and treat them as if they were left turns, which is not a great change as there was only one U-turn in the whole hour. The last row shows the volume settings used in Synchro, which is the total amount of volume for each movement from 5 to 6 p.m. For the lane settings, I provided a time settings image. This is because in this formula we are able to see the lanes settings as well as the traffic volume settings in a simpler way. Just to give a little bit of information, the prod and perm options that are shown in the term type means the following. The prod or protect means that it is required to wait for the light signal to make a turn, and perm or permissible means that it is allowed to make the turn at any time. Linear movements are used to decide which turn is first when waiting for the traffic lights, so there is no conflict between phases. The way it is set up is by identifying the phase where the highest volume is located, and that would become your main street. In this case, that would be our northbound and southbound, and that would make our eastbound and westbound our side street. The highest volume is always named phase 2. In this case, is at the northbound, which means that the opposite side, the southbound, would be number 6. Now to the left of phase 2 would be number 4, and the remaining should be number 8. For the lefters, which should be empty, there is a trick on where on our main street faces should add up to 7, and the side street faces should add up to 11. By following that trick, we end up with what we can see on the screen. And here we can see the signal settings. This was filled up with the information provided from the city of El Paso to adjust our signal timing settings. Finally, after adding all the parameters to our model and making sure that the model was optimized in its best capacity, now we can see the level of service in every direction. We can see that the intersection gets very crowded at the specific time period we choose, as most of the level of service shows an F, which is not a good signal. We can see that 97.4% of the intersection capacity is being used, which makes sense according to the LOS classification that we got. Synchro is a great tool to work with LOS analysis for macro projects. It's of great use, and it can be applied for projects coming up in my professional life. It's also taught me what parameters are required to make this type of analysis possible, and if I need to do something similar in getting a higher scale, I will know the basis for most of the upcoming projects that I should work on. Thank you.